Bismillahirrahmanirrahim. In this video, we'll study about per unit systems of measurement, and this is from Article 2.6 of Mr. Chapman's book. Now, we had seen in the earlier video that the impedance transformation from secondary to primary and vice versa is not easy, it is quite tedious, and therefore because such impedance transformation can be avoided, circuits containing many transformers can be solved easily with less chance of error. This method of calculation is known as per unit system of measurement. So we'll see what it is. In the per unit system, the voltages, currents, powers and impedances and other electrical quantities are not measured in their usual SI units, that is, they are not measured in voltage, ampere, watt, ohms, etc. Rather, instead, each electrical quantity is measured as a decimal fraction of some base level. And we'll see what does he mean by this. So any quantity can be expressed as a per unit basis by this equation, that is quantity per unit is equal to actual value divided by base value of the quantity. Now this may seem difficult. Let's go to the next slide and try. Okay, now we'll take a very funny example to understand this concept. Let's say there are two families. This family I'll call as the slim family and fat family, and they have girls, both the families. Apparently this girl is very slim as compared to this one, but let's see if we find the per unit value of these two girls. We know that the per unit can be found by the actual value divided by the base quantity. And in the first case, this is the actual value or actual weight of the girl, 12 kg. And we take mother as the base. So mother has 60 kg weight. So actual divided by the base value, we get 0.2 per unit. Now let's see the other family. Now this girl has 21 kg 8 and the mother is 100 kg. And in this case also the values very close, 0.21 per unit. So you see there is not much of a difference between the two girls if we consider them in terms of their family values or the family pattern. So this concept with mind we can now represent. Now let's say this is the circuit. We have a transformer, so the voltage is up here, and then again the voltage is down by 20 times in this case. Now all this can be converted into per unit, and you can see from here this has been converted into per unit, and we have now a simple diagram. So we'll see in details how this has been done. So with this concept in mind, let's now proceed. It is customary to select two base quantities to define a given per unit systems. So at least two. The ones usually selected are voltage and power, or the apparent power. So they are selected as the base quantity. And once we know the base quantity, we can then derive the other quantities like P base, Q base, S base is equal to V times I base. Z base can be derived from this, V base over I base. Y base can be derived from I base over V base. And again Z base can also be derived from V base square over S base. Now let's see an example. I hope this clarifies our many doubts. A simple power system is shown in figure, and this is power systems. This system contains a 10 kilovolt ampere 480 volt generator. So this generator has the rating, power rating 10 kVA and the voltage rating 480. Connected to an ideal 1 to 10 step-up transformer. So this is 1 to 10 step-up transformer. And it is connected to a transmission line. So this is the transmission line. It has its own impedance. The impedance of the transmission line is 20, 60, so 20 and 60. And then it is connected to an ideal 20 to 1 step down transformer. So 20 to 1 step down transformer with which the load is connected. And the impedance of the load is 10 angle 30. Now the base values for this system are chosen to be, as we mentioned, that voltage and power. So 480 volt of the generator and 10 kV of the generator are taken as the base voltages. Now we have to find four things. Find the base voltage, current, impedance and apparent power at every point in the power system. So this is one point, this is second point, and this is third point. Then convert the system to its per unit equivalent circuit. Find the power supplied to the load in the system and find the power lost in the transmission line. Let's see one by one. So first thing, find the base voltage, current, impedance and apparent power at every point in the power system. Okay, so the first point is in the generator region. So this is the generator region. This is given, V base is 480 and S base is 10 kVA. Remember, S is the apparent power. So two things are already given. So base voltage is given and apparent power is given. We have to find current and impedance. So we can write that current, or I base 1, is the power base, S base divided by voltage base. So I base 1, we can find this and we can subsequently use this I base like it has been done here. To find Z base, we'll use the formula of V base 1 over I base. V base is 480, I base 1 we have calculated from here. So putting this, we find the Z base 1 for the generator region. Now we come to the second region. The turn ratio of the transformer is alpha is 1 over 10, that is 0.1. So this is the turn ratio. Now in the transmission line region, that is in this region, the base voltage will be, obviously it is a high voltage, so 10 times high. So base V base 2 we can find as V base 1 divided by the turn ratio or the transformer ratio, which is 480 divided by 0.1, so 4800 volt is the base voltage here. Now base voltage we know, the other quantities, power remains same throughout the circuit, the power does not change, so S base 2 will be 10 kVA, and from here now we can find I base as we did here, same formula, and also we can find Z base, same formula, V base over I base. So this is for the second region or the transmission region. Remember, this power is same, but the voltage here is from V base we found out 4800. So divided by that we get I base, and then we can use that to find Z base 2. And okay, now we will work on the load region. Now the turn ratio of the transformer T2 is 20 over 1 equal to 20. So this one 20 and 1. So in the load region, the base voltage V base 3 will be V base 2 divided by A, so it will be 240 volts. And similarly now S base again remains constant, So we find I base and V base by the same technique, S divided by voltage, we get I, and then voltage divided by current, we get Z. So we have found now all the parameters in the three regions. And now the question, second part is convert this system to its per unit equivalent. So we had found these in the generator region. The V base is 480. I'm ignoring all the other three parameters that we have calculated because we'll only be using this in this example. Then in the transmission line region, Z base we had found to be this value, and in the load region we have found Z base to be 5.76 ohms. Okay. So to convert a power system to a per system unit, each component must be divided by its base value in its region, that we have understood. Okay, so the generator region, what is the actual value? 480 angle theta, and the base value is 480 volt. So divided by that, the voltage at the generator in per unit will be 1.0 angle 0 per unit. So this, we have converted this. Now we move to the second side. So this is the generator portion. We can write it as 10 pu. Next we come to the transmission line, the actual value divided by the base value. Now the actual value is this, and the base we had found out already, 2304, so we divide by that. So this is the Z line in a per unit, and so our circuit now will look like this. And finally we move to the load side. So Z load is the actual value divided by the base value. This is the actual value, and the base value from here you can see 5.76. So divided by that, this is the load per unit. So this is our complete circuit in per unit. The currents are same because it is all in series. And now we come to the third part. Find the power supplied to the load in the system. Now we know the per unit power of the load will be I square into R. So I square pu divided by R pu. This was the circuit. Now we don't know RPU because this value is given of Z, so we have to calculate the RPU. Now current we know, current is VPU divided by Z total PU. So V divided by Z total will give us the current in PU, which is 1.0 divided by all the impedances, all these. And the final result is this. Now at this point I would like to highlight that you can use your calculator in the complex mode to directly find this answer. If you don't know how to, I have a video on how to use calculator on in complex mode, so just go through that. It will become very easy instead of converting all these into polar and rectangular and back to polar, etc. So this is the direct answer you will get. So this is IPU. Now we need RPU. Now RPU, as I was mentioning, that the ZPU is given. So if we convert this into rectangular form, then we get 1.5 J, this one. So this is the real value and this is the imaginary part. So for power calculation, we'd use the real value, and that is why we have used 1.503 RPU. So this is the power per unit power in the load. And now if you try to find the actual power, then we have to keep this diagram now in mind. If we have forgotten how much was the weight of this baby, then what we have to do, we know the PU, we know the base value. So if we multiply this, then we know that the baby weight was 21 kg. So exactly same thing will follow here. That is, to find the actual value, we multiply the per unit value with the load. So power load in per unit multiplied by the apparent power or base power, which was 10 kVA. So the power load is 4870 watt. So this is the third part. And finally, find the power lost in the transmission line. So we know the transmission line parameters. This will cause the loss, the resistance. We know the current. So I square and R line PU. This is R line PU. So this is the power loss in the line in PU. And again, if you want to find in watts, then you multiply by S base. So this is the power in terms of a watt. Okay, couple of more points. When only one device, that is transformer or motor, is being analyzed, its own rating are usually used as the base for the per unit system. So this is very important. If there is a single device, then that device own rating will be used as the base. And let's see one example. So example 2.4 is sketch the approximate per unit equivalent for the transformer in example 2.2. And in example 2.2 we saw this is the transformer rating. 20 kVA is the power and 800 over 240, these are the voltages, primary and secondary side, and 60 Hertz. So he's saying that use the transformer's rating as the system base. And this result we had got from example 2.2, but all these values are in ohms, not in per unit. So basically we have to convert this into per unit, and this circuit is referred to the primary side. So how to convert to per unit? The primary circuit base impedance must be found. And Z base 1, that is the primary side, is V base 1 square over S base. You can find from here. If you have difficulty, we know S, that is the apparent power, is V into I, where I can be written is V over Z. So apparent power is V square over Z, and from here Z will be V square over S. That is what we are following here. So putting in the values, we know the V base is 8000 and S base is 20 kVA. So we plug in this value. So our Z base 1 will be 3200 ohms. So we have found the Z base. Now we'll divide all these with the Z base to find NPU. So Z of the series portion divided by the base, this becomes in per unit. Similarly, this divided by the base, 49.7 per unit. Similarly, 38.4 divided by the base is 12 pu. So this circuit now we can convert into pu, and it will be just like this. We are just changing the value. 159 kilo will now become 49.7 pu. Similarly, this one will become 12 pu, and similarly the other two in pu. So this circuit is now converted into per unit. And the final note, if more than one machine and one transformer are included in a single power system, the system base voltage and power may be chosen arbitrarily, but the entire system must have the same base. One common procedure is to choose the system base quantities to be equal to the base of the largest component in the system. So if we have to deal with more than one, then we have to keep this point in mind. I hope this gives you an understanding as to how we can solve this type of a problem, which apparently looks difficult, but step by step if we go, it becomes easy. Thank you.